All right, we are continuing on in Unit 1, and we are going to graph some transformations today. So first we're going to look at the parent functions that you learned about last year and just quickly review them. For absolute value, for every value you put into your function, a positive value is going to come out. It's asking how far away is that value from 0. So if you put 1 in, you're going to get 1, 2, 2, 3, 3. However, if you put a negative 1 in, the absolute value of negative 1 is positive 1, which is why we have this V shape. So a quadratic, x squared, 0, we put in 0. If you plug in 1 for x, 1 squared is 1, and then 2 squared is 4. Now if you put in negative 1, you're going to square the entire quantity, negative 1 times negative 1, so you get a positive value. And we get this nice parabola shape. Moving on to the cubic. So if you put in a positive value like 1 and you cube it, you get a positive value. However, if you put a negative value in and you cube it, negative times negative times a negative, you end up with negative. This is an odd function. So cubic is an odd function and the quadratic is an even function, which is what we learned last time. All right, square root. Square root. So we can't have anything under that radical being anything less than 0 because we're not going to be able to graph a square root of negative 1 that's imaginary. So we start at 0, square root of 0 is 0, square root of 1 is 1. Next nice number to square root, take the square of, would be 4. So square root of 4 would be 2, and then of course 9 would be next, 9 and 3. So these are parent functions, and a cube root, again, we're just following the same, we're picking some nice values. 0, 0, if you put in 1, you get 1. And because it's the cube root of 1, if you put in negative 1 and take the cube root, you get negative 1. So these are the points that that I use in a transformation when I have a horizontal or a vertical shift, which is coming up. So here's an example. Example 1, horizontal shifts. So if you have a horizontal shift, basically it's a shift inside the function. What happens is if you plug in, for example, negative 3. Negative 3 right here goes in for x. Negative 3 plus 3 makes this parentheses equal to 0. 0 cubed is 0. So the shift has gone to the left 3. So a lot of people think, well, shouldn't it be the same direction as the sign? Because this is a plus 3, it actually ends up being the opposite. If we were in class, I'd show you the graph paper moves to the right 3. So the graph essentially goes to the left 3. But if you know your 3 points from your parent function, okay, here 0, 0, 1, 1, negative 1, negative 1, you can just shift all those 3 points to the left 3 and be done, and then just draw a nice little curve. Okay, same for the square root of x minus 5. So if you know you've got 0, 0, 1, 1, and then 4, 2 from our parent function, you can just take those 3 points and shift them to the right 5. Here, here, here. Done. And then draw your graph. Vertical shifts are the same direction. So we have a minus 6. We're going to take our main points. I'll just use 0, 0, 1, 1, and negative 1, 1. And we're just going to take those three points and we're going to move them down 6. So 1, 2, 3, 4, 5, 6. Negative 6, negative 6. And then you just draw your graph. Okay? So cube root. So we've got 0, 0, 1, 1, negative 1, negative 1. Now be careful that this isn't, those are the same points that you would use in x cubed, but this is cube root. But we're going to take those values and move them up 3. So they all move up 3, and then you draw a nice smooth curve through it. All right, example 3, vertical dilations. So it's either a stretch, expand, if you're multiplying by a number that's larger, if its absolute value is larger than 1, or you're shrinking or compressing, if it's a fraction, between negative 1 and 1. So let's start with just the parent function of x squared. Okay, so those are the numbers we'll use. So 0, 0, if I plug in 1, I get 1, and if I plug in 2, I get 4, right? So what happens when you shove a 2 in front here of the x squared is that the x coordinate stays the same, but then the y coordinate doubles. So you're still plugging in a 0, and you end up getting 0 because you square it and then multiply it by 2. But once you plug in 1, you're going to get 1, but then that 1 is going to be multiplied by that 2. So it's going to be twice as high. And same for 2. 2, 4 is now going to be 2, 8. Okay, so you're stretching or expanding. So here's your regular function, and it's been stretched. And that can happen with negative values too. It would just be down here. So a shrink or a compress, so here's your standard parent function, 0, 0, 1, 1, 2, 2, 3, 3, and so on. And there's your graph, very lightly sketched there. However, if I take those values and there's a 1/3 weighting for it in front, when I plug in 3 for x, I'm not going to get 3 anymore. I'm going to get it, the absolute value of 3 is 3, and then I'm going to multiply it by 1/3, so that will end up being a 1. So that's why it shrinks. So basically the quote-unquote slope is not as steep. All right, I think I skipped a few examples. We are moving on to example 5, reflection over the x-axis. So what happens when you put a negative in front of the function? Okay, so these are regular parent functions, you just put a negative in front. What happens is your point like 1, 1, that was on the irregular parent function, there's a negative weighting in front for it. So when you plug in 1, you're not going to get 1 anymore, you're going to get negative 1. So it's a reflection, all these points are reflected over the x-axis. So the y values, if they were negative before, become positive, and if they're positive, they become negative. So that's why it's a little flip there. And same here, this point is being reflected down here, and this point is being reflected up here. So moving on. Reflection over the y-axis. Okay, so if you have a negative inside your function, notice the reflection over the x-axis, there was a negative in front of the function. Okay, now if you put the negative inside the function, what happens? Okay, so 0, 0 will stay in the same place. Okay, but let's say the parent function, let's do 4, 2. That's a nice number. So if I'm putting in 4 here, well, suddenly what happens? I basically, that becomes a negative 4. So it's going to be square root of, hold on. Okay, so if I were to put that in, I'd have the square root of negative 4. So we're not going to have any graph over here. But what we can do is, if I put a negative 4 in, negative 4 for x, and there's a negative weighting for it, that will make it positive, and I can have my value over here. So the graph is just being reflected over the y-axis. So the point 4, 2 would be at negative 4, 2. And what happens sometimes when you have an even function, these points are reflected over here, these points are reflected over here, and they just reflect upon themselves. That's what's happened in B. And now we're getting to multiple transformations where this is kind of what you're going to see. So you might have a horizontal transformation in a quadratic, but you're going to know there's a squared there. So we know the graph is going to look like a parabola. It's either going to open up or open down. We know this one's opening down because there's a negative in front. And then it's going to be shifted up 4. So this means, let me erase all this. Well, it's okay, I can leave it. This means my original points are going to go left 2, up 4, and then all the y values are going to be multiplied by negative 2. So you can do this in whatever kind of order you want, but usually I like to think about my parent function at 0, 0 and figure out where is that 0, 0 going to go. It's going to go left 2 and up 4. Okay, and then from there, you can think of that as your new 0, 0, where would your points go if that was, y equals negative x squared? Well, they would go at 1, negative 1, 1, negative 1. Okay. However, we're being multiplied by a 2, so they have to be twice as big, which is why they're down here. And then you go over 2, down 4, but instead of 4, it'd be 8. So over 2, down 8. Now, if you want, you can plug these points in separately, but the point of this lesson is to learn how to take those points from the parent functions and just move them. So here, this one's a little tricky. First thing I did was I factored out a negative 1, because now I can see there is a horizontal shift to the right 4. So I'm going to write that right. Why is this not writing? There we go. Right 4, down 2, and then all the y values are going to be multiplied by 3. And we've got a reflection over the y-axis. So that 0, 0 is going to go right 4, 1, 2, 3, 4, down 2, down 2. So there it is. And now from there, instead of going over 1, up 1, I'm going to go left 1, up 3. Left because of this negative, and 3 times 3 because of 3 in the front. So the next point for your square root is 1, 1, right? If it's just y equals square root of x. Let me show you here. 1, 1. The next one would be 4, 2, right? So we'll still go, erase, go away. Come on. Let's to go over 4. 1, 2, 3, 4. But instead of going, what? Hold on. Up. Okay. Instead of going up 2, we're going to go up 2 times 3, which is 6. So 1, 2, 3, 4, 5, 6. So there we go. So you might have to rewind and read and look at that again. So that's kind of complicated. And the last thing, I think, no, not the last thing. Example 8, we have one more example in example 9. Sometimes you'll be asked to write the equation. So y equals x cubed is shifted to the right 3. Okay, so that means y equals, we're going to have, it's going to be right 3. So that means x minus 3. And then up 2 is at the end. And then vertical dilation of 1/2. Okay, I don't know if we saw that exact wording in the example, but put your 1/2 in front. And didn't we have something else? Oh, it's reflected over the x-axis, so negative. There you go. And if you need to look at that a little bit more and go through your notes and see why that negative is there, just look back at your notes. And the last two problems. Okay, so finding a point. So the point 4, 2 is on the graph of f of x. What is the point on the graph of 2 times f of x minus 3? Well, all you're doing is multiplying the y value, because f of x is y, by 2 and then subtracting 3. So here's your y value. So you're just multiplying 2 times 2 minus 3, and you get 1. So your x coordinate is the same and your y coordinate is 1. And the point 4, 2 is on the graph of f of x. Okay, same again. What is the point of the graph on f of negative x minus 4? So now we have to make the x value negative, and then we have to subtract 4. So the x value is 4, right? Here's our x value. So we're going to plug that in. Negative x minus 4. We get f of negative 8. So that's our x coordinate, negative 8, and our y coordinate remains the same. All right, I hit almost exactly 15 minutes. Peace out.